Alright, looks like we are live. Okay, so welcome to part 3 of what is the bowling simulator, 10-pin bowling simulator, I suppose. We've obviously come a fairly long way with this. I'm hoping that this third piece will be the last, but we'll see. So when I was working on this between parts 1 and 2, I kind of realised that the design wasn't great. So when you watch sort of 2, you notice to take it in a different direction, and we've sort of thrown away the player turn class essentially. So one of the things that I also did skip out on, missed, was the fact that I actually got trompe l'oeil to work nicely with catch. And the secret sauce to this was, in fact, that if we look in the main, there's this piece of boilerplate code here. So we enter the trompe l'oeil namespace. We then have a empty template specialization basically for the send function. This is I believe handled by catch essentially, or seen by catch. Oh no, sorry, it uses catch, and so this will spit out the failures and use a few catch macros. And then what you have to do, because obviously this is a template, is essentially declare it as external so that you don't end up with multiple copies of the template. Otherwise, if you do, it won't link, which is obviously not good. So, following on from where we were last time, I didn't really do much more with it, or barely anything in fact. So we created our frame set last time towards the end. Obviously watch part 2 if you haven't seen any of it. I should probably mention that we're live streaming to folks. Okay, and essentially we sort of implemented a fairly simple case where bowling nothing but empty frames would obviously correctly give us the score of 0, which by and large we obviously faked. And then we've added one where scoring 5 once gives us that score of 5. So I'm pretty sure this will compile and run, but since I'm picking it back up, it's always good to check. And yeah, there we go, it's good. So just to explain what's going on, partially for my own benefit, since I've forgotten part of it. We now obviously have this wrapper, or not wrapper, but convenience function as part of the tests, and this will create a set of mock implementations to fill this array in. We'll then create a vector of references. So we don't really care that it's a vector in this particular case, it's just convenient and it's only for the tests, so we don't mind. And then it will obviously return the object. Obviously it does it by move, because this has to be moved anyway. And really the rest is for convenience, of course. And then what we'll do with them is we actually execute our require call. Now, one of the things I discovered that I didn't obviously know in the previous live stream was that the lifetime of require call is essentially whatever its scope actually is. So, for example, where we do a require call here and here, that needs to be satisfied before we exit this iteration of the loop. So that's okay because I just call bold here, and then that, if it passes, we'll execute both of them. But the problem I had was that to actually handle calling score for each iteration, because obviously there's what, 10 frames, and at the end we're going to ask for the score. It needs to obviously live on, because the point is that I don't want to have to call this 10 times outside of the loop. It's just annoying. So now we can call it inside the loop, and it stores them in this vector of expectations. And because they're stored in the vector, which lives outside of the loop, they obviously will live on. So that solved my issue with the mock framework. And of course, what we do is on the fourth. So not the fourth, that's technically the fifth. 0, 1, 2, 3, 4. Yeah, on the fifth frame, it will return a open struct into the variant with a score of 5. Obviously, they're all defaulted to returning 0, so this acts as an override. When we're in this loop, it will set the same one to allow a call to score, which we then override to return 5. So obviously, we then check that everything's ended, and we check that our score is 5. So we've obviously handled the sort of trivial case here, because all this can actually handle right now is when a frame is open. So it has to return the score and go on. So there's a few options for where we can go from here. So one of the ones I'm considering is we could essentially simulate returning all strikes. So we would have it handle when it's when it gets a strike. But then it has to, of course, compute the final score. Alternatively, I could go with just doing one of them being a spare, but then a spare gets a bonus of the next frame. So the subsequent roll essentially acts as a bonus. I'm inclined to go with the all strikes case. We know it's meant to be 300, so that's fairly simple, and that would obviously cover that particular case fairly well. I think we're going to go for it. I think we're going to. So let's start out with our scenario. So scenario, a frame set, we score nothing. This is nothing. No, I was going to say nothing but score all strikes results in a score of 300. So given a frame set 10 frames, and of course we go. And actually, one of the nice things about the design here that you might notice is that currently we do have it restricted to 10 frames, but there's actually nothing in this code that would prevent you from arbitrarily redefining this number, or using a vector, arbitrarily redefining this number to effectively an infinite number of frames, as long as the final frame is always that special final frame type. So we are going to go ahead and start mocking. So obviously I think I can just grab this, and it's going to obviously mock frames.first is the array. So this returns a pair, so we have a stood pair, and the first is the array and the second is the vector. So obviously the array is for the implementation, the vector is for us in our test to utilize. So we have a given, and then we're going to say when bowl all strikes, or say bowl all games, sorry, all games, and all mocks are set to report strike, and I can pretty much reuse this loop. I obviously don't want turn ended to be false then true. It's just going to, well, actually that's not entirely true. The ninth one is going to, sorry, the 10th one is going to let you bowl 3 times, obviously. So we'll set up the first 9, I think, and then we'll set the final one up. Well, actually, it might be simpler just to do this and then override it, but no, because we require a call, so it's going to have to be 0 to 9. So it's okay. It's going to be slightly different. So we can again do our. Do I even need to do the expectation? I can just cover all. No, we're going to cover all 9 of them and then move out of it, so I don't need the vector at all. So here we go. For so I is 0, I is less than 9, increment I. And now we'll start doing our stuff. So the first thing is we expect it to call it once, so require call, what is it going to be? let's use an alias for this. So we'll do auto-ref frames equals frames.second. So then we can require the call, so frames by. Will that use a conversion operator? Probably won't. It's okay. Just do .get. And then, of course, we're going to expect it to call bold, and it'll be any const I inset ref. And of course, one time. There we go. Now, I see the std reference wrapper does have a conversion operator, but I don't think that's able to. Yeah, it can't load it, of course. So that takes care of saying that the bowling has happened. Now we're going to, of course, do require call on frames I.get, and it's obviously going to say turn ended. It's true. So I hope that makes sense. If you get a strike, you only bowl once, and then your turn is ended. So after that, we can then just handle the final case, which is obviously special. So we can say frames 9. Obviously, it's the 10th element, so it goes 0 to 9. Dot get to require call. Bold any const I pinned set ref dot times 3. So obviously you can bowl for each on the final frame. You can bowl a maximum of 3 strikes. We're simulating getting all 3 of them. So consequently, we require this to be executed 3 times. As it should be. And then of course we need to return the correct turn ended a certain number of times. So I'm going to create a sequence now. So we've got our sequence object, and we can say require call frames 9.get and ended. Return false 2 times. Sequence S. And then of course we're going to just clone that. It's just going to be once. I don't know why I just decided to indent it for me again. So that sort of solves or covers the action of bowling all strikes. Okay, then our total score should be 300 and set ended. And check. I'm just going to get the console to ref. It's good to have mutable and switch to const when you need to, because it will force you to be const correct. I think I mentioned this in previous runs, of course. So that should be true, and then check set score. It's 300. So obviously we expect this to fail. I'm pretty sure it's going to throw an exception, in fact. And of course, it does. And there's quite a lot of rubbish here now. Yeah, so, okay, for one, the test is failing because we never actually called bold, so I should probably fix that for starters. So, just give that a temporary mock, because we don't actually care about the value. So we're going to tell that we bold there, and then of course we need to do it one more time here. Let's type. There we go. Okay, so now it will actually bold, rather than just done absolutely nothing with the implementation of any use. And let's see what we've got. Obviously, fairly short errors now. No match call, score, signature score T. Yeah, so obviously we've got our first sort of simple failure. So let's try and reduce the failing. So the first thing is it actually the score? Yeah, so it's right when we call for the score actually. So we do seem to be correctly reporting that the turn has ended, mainly because it just returns true. So we'll add a test for that later. But in terms of this, obviously, we just call stood get, and we only call stood get. So probably the simplest way to utilize this is if we implement a visitor pattern. This will do two things, because obviously I am forced to generalize now, or I'm not forced. I could try and get around it in a bit of a silly way, but this is the point where I need to generalize at least to some extent, so I might as well do it properly and safely. So a visitor pattern is certainly the way to do this, and the way in which we're going to do that is we're going to have a private inner class essentially, and then we can interact with it as we like. So basically we'll have a class, we'll call it frame visitor, frame score visitor perhaps. Yeah, I think frame score visitor is fine. And then what we're going to do is we'll just implement the various necessary operators that are required to make it work. So obviously the first thing we want to do is just refactor this to service what we currently do. And so we need obviously we need an operator for this. So it's going to be, what value is this? Dot total. Need to handle an open. I could return the type, I suppose. That's one way of doing it. Yeah, there's a few ways that we can visit this, but the basic principle. So let's just say that we know we know what we want from a score. So it's a total. So we'll have a uin fast at operator, and then of course the arguments it needs are iframe open, and we'll just take that by const ref. And then of course we need to return it, so just to return sort of total. And that's implemented that for us. Which means now if we just comment this out, replace it, we can say ret plus equals, and frame score visitor. Oh, you know what I've forgotten to do? I'm really sorry, everyone. Let me fix the view. Presentation mode. There we go. Right. So now that you can read it nicely, I don't really like this view, but I suppose it's more helpful for reading. So we're going to visit a frame score visitor, and we're just going to pass it the score value. So you may think that's good enough, but I believe it shouldn't be. Why is it complaining? It is users right now. If we try and execute this, we should have compile time error. And here we go. These are very useful. Let's see. frame score is no serious function templates. Error. Yeah, unknown type makes sense. Right, the following type template arguments. C declaration same, blah blah blah. So this isn't the most helpful error from Visual Studio, sadly. But I know. So basically, what's wrong is that if you want to implement a visitor, you cannot compile unless your operator parentheses implement all of the possible types that the variant has. So I can't just do open and leave the rest unhandled or non-existent. So let's just go back to our project, and we're going to go to our iframe. We have our variant here. I'm just going to copy and paste it because it saves me a bit of time. I'll delete it afterwards, obviously. So we've got our open. Obviously, we then want one for a strike. So I'm going to just mark it void for now because it doesn't matter what the return type is. That's for our usage. So we can take a cont iframe strike ref. And we've implemented that one. And then we can have a const iframe spare ref. And then of course spare with bonus ref. And then finally the free strikes. And we take a cons ref because whatever it is already exists and combine to it without any overhead. So now, hopefully, it should be enough code to. Oh no! Oh, didn't delete the line. Right, if I do that, still doesn't work. What have I done wrong? As it requires resolve all potential applications to have the same type and value category. Okay. So I'm just going to do this. They must all return the same thing. It doesn't matter. Okay. So now in theory this will work. It still doesn't work. What's wrong now? They don't return a value, which strictly speaking isn't illegal C++, but we're just going to return 0. Visual Studio is very helpful. It doesn't let you do UB. Undefined behavior. This one. Yeah. So now we've got our case. It's still just this one failing, of course. So we need to get it to pass, obviously. So we got rid of this. Didn't break the existing test, but I need it to succeed. So obviously the silliest way of making this pass is return 30. 30 times 10 is 300. This should work. And it didn't. That's because we screwed up the test, I think. So on the third one, we are supposed to call bold 3 times. So since it's not many, we're just going to do that, and that should obviously be correct. Or not. What failed? Oh, no, actually called score, so I just called T. Due to an exception message. Because I'm probably not doing it. Did I? Oh no, did I set it to return the score? Bold, yeah, turn it did, but not the score. I didn't get it to return the score, which we're going to do at the end, so sadly I do need the expectation now, after all. So this test is still wrong. So what we need then is to have this, and then we can have a named expectation here. and we can just pop that in straight there. And of course, it's going to return a strike instead. Acceptance frame is fine. It's a little bit long for the screen, so that can pop itself down there. Just to make it a bit more readable, finish off the brackets so you can understand where it's coming from. You know what? Let's do this. There we go. That's much more readable. So we can place that back. It's going to return a strike, and then of course on this one, this special one, we need to then obviously acquire called frames 9. Yeah. I could also use frames.back.get. That would work just as well. And then of course score return strikes. So now it's going to return all the correct values. We need to actually handle 3 strikes, so we're not going to pass just yet, but we should at least get a bit further. So we're in the scenario. There's no mock exceptions, but the score is obviously not correct. So what did I do wrong? Go for the frame set. Oh, it's 30. That's interesting. Oh, of course it is, because we only did the yeah. So these can be 10. Turns out, no, that's not right. It's 30 all the way through. And that of course works. It's not very useful because it's essentially a lie. But we are getting somewhere. I think there's actually a slight problem with using this visitor pattern because it needs to actually have state essentially. So at the moment when we use this, and we don't have a test yet that cares, but constructing this here means that we make a brand new one each time. But the whole point of the visitor, right, is going to be that it needs to know about prior frames in order to actually calculate a score. So of course I've got a passing test, so if I want to do something sensible or force it to do something sensible, I need to create a valid scenario in order to pass it. So from my thinking right now, I'm probably going to go with saying that if we get, say, nothing, and then a strike on the 9th frame, followed by 3 strikes, then I believe we should have a score of 40. Let's just test that in a good old scorecard here that I have. The spec saves me having to work it out on paper. So let's see, if we score nothing until the 9th frame, we get a strike, 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 strike. Of course it's 60 because you get the next 2. Why is it 60? 10, 20, 30, 10. So frame 9 gets bonus of 30. Then the first strike gets a bonus of, sorry, it's bonus of 20, so 9 is 10 plus 20. And the next one is going to be 10 plus 20 again. That's 60, of course. Okay. So let's think through this scenario. So scenario, scoring right on the 9th frame and 3 strikes. So I'm just going to essentially copy most of this. You can edit it. Well, it's going to require a little bit more code. Slow it down a bit. Let's go for this first of all. So given that, just close it out. Okay, so when we roll against we roll. What is it? Nothing on the first 8 frames, and this time it's going to be 0 to 7. It's going to roll twice, and then of course I need the alternative behavior. Should be all right. Wait, what have I done? False true. Is this correct? No, yeah, well, it was 2 and then 1. So I'm going to say this. Actually, let's just take all of this. Let's take all. Now I'm getting confused. Let's just get rid of this and stick to it. Right. So frames by those minutes are more accessible. Got a reference now. Frame, and of course we're going to require comment frame again, and again. Bit of a risk doing copy pasting, but let's just make sure this is correct now. So let's think about it. Going through the first 7, the first 8, we are expecting to roll twice. Turn has not ended, then your turn has ended, and then it's going to say that you've got nothing, and we roll twice in order to do it. And then for the 9th one, we need to obviously handle that. So and when bold strike on the 9th frame. So obviously that's going to consist of bowling once. So frames. I should put the and there. I do not like that. Frames 8, and that's going to be once. Obviously your turn will have ended immediately. Just nab that. And I don't need a sequence. I think this is short enough just to leave it there. Right. So we bowl, your turn has ended, and then we just need it to return a strike. So strike. And then of course we need to actually bowl. And when bowl strikes on the 10th frame. So again, I just need to clone pretty much all of this. What do we call bowl 3 times? Turn ended, score, and take that all. Okay, we can say then should score of 60 turn ended? Ended. And of course it should fail first. And it has not. So what have we done wrong? We failed to generalize. Let's go and analyze what's going to happen. So that's going to return 30. Then that's going to return 30. And it's just going to pass. Because that is in fact 60. Well, if I move it down to the 8th frame and we score nothing afterwards, then that's just going to be 10. That would force me to generalize some of it. I actually think that the free strikes score is always 30. Now, I think that, technically speaking, that visitor pattern might be correct even. Let's just start another game, and for that particular game state, let's see what we actually get. If I then go strike, 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 it is in fact 30. So this is pretty much correct. It won't ever need changing. You know, it will because I need to know the attributes of the free strikes potentially. So I need to think about design a little bit better before I get into this. Let's just envision this. So imagine I get a strike, and this was a free strikes, then I know I need to add, say, I would add 20 to the previous. If I get a spare, I need to add one of them, so that would be plus 10. If I got a spare with bones is of course from the final frame, so that's different. But what do I do in terms of adding? So I need to track the last one. Although we can of course visit it. So we could potentially call for the score multiple times. Call for the visitor multiple times, although that might be a problem with my test. I might need to update them to execute that. Although that's actually fine. That's fine because we have separate mock objects, and obviously the real implementation just has a constant score, so that wouldn't matter. Yeah, this should be stateful in some way, so that as it's operating on the score, it knows an initial score, what to do. So how can we force ourselves to generalize this solution? I think we're not going to change anything necessarily, but we are going to refactor a bit. So I'll leave this test here because you verify that it is correct based on that code. So we'll leave that there for now. But we're going to do a refactor, and it shouldn't break any of the tests. So we're not going to add strictly any new code. We're going to move it around. So the first thing we want to do is move this into being a stateful object. So we're going to cut it out here, pop it in here, and then do that. And then we can just do return f as visitor. And of course we need a conversion operator for that now, so we can plug that in. So and we can have our return type. Initialize that to 0 and just return it here. Let's call it score, but it's silly, isn't it? Or total. And of course, this should be commonly accessible. So we've now got conversion operator, and then this can compile, but it's not going to quite do what we want, so we don't need this anymore. We just call visit, and of course we just do total plus this, and total plus equals that. Yes, that is not a typo. Clearly not. We could probably return a const. This returns by value. We could do a const ref here, but I think it's pointless. So in theory, we should continue to pass. This is just a refactor. Yeah, it's not returning anything. We don't need to anymore. It's all in the state. And in fact, just leave these empty now. Okay, so with that done, our basic visitor pattern, and it still does the same stuff, passes all the same tests. So probably a better way of testing this is if we say that on the first frame you get stripe, and then on the second you get 7. There should be a total of 17, and then you miss all the rest. So let's see, we can borrow from. Now let's just write it from scratch. Make this mistake. So scenario. Actually, no, it's not going to be 17, is it? It's going to be 17 plus 7. I'm going to just double check now. So we'll strike 7. Yeah, 17. 24. 17 plus 7. Score 24. And I will just copy this little bit. Then bold strike 7. Put me outside of that, please. So I now need to. Do I have the mocks? Yeah, I do. So on the first go, where have I simulated a stripe before? This will work. So that's the first one, and that's going to do everything. You know what, I can just copy this sort of. So obviously it's going to bold twice. And we need to then turn open. type it's total, first and second. So we're going to say 770, I think makes sense. Not that one. 770. So that's a total of 7. Got 7 in the first, 0 on the last. So it shouldn't matter which way round this is. I need it in a sequence though, don't I? So we're going to sort it. Should be a nice one somewhere. This will work. I think I'm going to shrink it down for this one. Yeah, it fits with this font. That's good enough. Right. This is the second frame though. Right, so obviously you're going to bowl twice. First time we only got 7, so you get a second chance. Second time, obviously that's it, it's over. And then the score is obviously going to be total 7, 7 first, 7, and 0 on that last one. And when there ain't no outside of it, don't do that. And when you bowl nothing, yes. And I can obviously just copy the loop for this one. Return this. That returns a strike, isn't it? What's going to do? This should do it, shouldn't it? No, not that. It's fine. So we got an expectation. We're not going to use this loop though, so we're going to say we're not doing 1, we're starting from 2, 9 is less than 9, 10. Although for that final one, do I need to treat it as a, because it is mocked, it doesn't necessarily know. In fact, no, it doesn't. So it's going to be a standard, it wouldn't matter anyway, if you miss, you just get a standard 2 shots. So frames I, and of course that. And then you bowl. So let's just validate that. We've got 0 covered, we've got 1 covered, and then we've got 2 covered because you bowl twice. First time it hasn't, the second time it has, and then finally your score is going to be 0. I just should check if I initialize these by default. Do I? I do, so I don't actually need to do anything. The default initializes quite safely. Part of me wants to get rid of it because even though it looks explicit, it's actually missing 2 arguments that are set to 0. But I think it's probably okay for now. Just an explicit total of 0. And should probably force that though. But in any case, that should do everything. Say then so our usual const ref. Game should have ended. fail if it would like to run. There we go. And what do we get? A failure. Good. Just what we wanted. So let's just make sure it's the kind of failure we should be getting. No match recorder score is going to score T with score to 24. No match recorder score is going to score T. No, what have I done wrong? I'd expected this to be called we did bolt. Oh no, we're in the loop. Oh, that's foolish. Why is that weirdly indented? Just because it didn't fix this up, hopefully. Oh, we've got one extra curly brace to get rid of. There we go. Okay, now it should fit in the way we're expecting. Or not. No, something's still wrong. Oh, because we only bowled once here, we should have bowled twice. So we're out of sync. Alright, what's this saying now? There we go. Now it's what we expect. So it's supposed to be 24, and in fact it's 37. Right. So we need to fix that, obviously. So now we go up to our sort of little quasi state machine here. And we need to essentially account for reconciling a given score bonus. So now I am actually completely forced to generalize this with this one test, because I can't simply add 30 for a strike, but if you're getting all strikes, then we need to remember that. So let's just think about how we can avoid breaking the strike state, essentially. So if we end up in a strike, then we need to know what the next two scores effectively were before we can add it to the total. So I need to track each strike and add the score to it. So I'm tending towards saying if I'll have a pending strike class. And what's the maximum number of pending strikes I can have at any one time? Well, I get a strike, so that's pending. And then I get another strike, so that's pending. They're both pending. I get something else, say it's another strike, then I can pop one off and pop another on. So basically the maximum size here is guaranteed to be 2 strikes. So I know the value of a strike. If a strike is pending, let's see, if a strike is pending, I also need to know when I've counted 2 scores against it, so I can't just do a simple counter and go done, done. Or can I generalize this to the concept of a pending bonus? I think I can generalize to the concept of actually a pending bonus, because if you get a spare, you have a pending bonus of +1, and if you get a strike, you have effectively got a pending bonus of +2. So let's test that idea out and see if we can avoid breaking the code. So what I'm actually going to do, well, actually no, I won't, because I might have broken it. So what I'm actually going to do is I'm going to have a just a unit T again, doesn't need to be very big, so max of 2, pending bonuses, initialize to 0. So now we can say if we get a strike, then pending bonuses. Actually, let's not do that. So we know we need to add 10. It's worth 10. And then if pending bonuses, we can say total again equals another 10. And then decrement that. And then, of course, finally, we finally have 2 pending bonuses. So counted for the score itself. If there are any bonuses, we use this strike to accumulate for that. We knock one off because we've now awarded the bonus. And then, of course, we're going to add 2 irrespective, because that's, of course, what we've got available to add to the score. So then, of course, we need to handle the 3 strikes scenario. So we can then again add, we know, actually, do we know we can add 30? Yeah, that's always going to be 30. And then we just use a while loop because it's the final piece of scoring the game. So while minus just add 10. I think. Let's just think that through. So if you get a strike on the final on the 9th frame, then that's going to have pending bonuses of 2. So 2 is obviously not false. So we will do give you 10 points, and then we'll come back around. It's now 1, decremented to 0. Give you another 10 points, but it's now 0, so you're done. So yeah, in theory, that should still not break the strike. So let's find out if that's true. And what do I do? Getting a strike on the first frame and 7 next gives a score of 24. Yeah, so this logic didn't break the scoring for striking. So now I just need to handle having an open score. So if you have an open score, we know that we can award the bonus for the pending bonuses. So the question simply is whether we need to whether there's only 1 pending bonus or 2 pending bonuses. So we always add obviously the total of the score, and then we can just say if pending bonuses is greater than or equal to 2, then of course total plus equals score dot first plus score dot second, and pending bonuses plus 2. Dealt with 2 of them obviously. pending bonuses. And I could compare it to 1, but it can only be more than 2, or it can be 1. So I can just test. We'll be explicit. I think that's probably better. It's more idiomatic. Then of course we can say that the total plus equals score dot first. So we count the first one, obviously, and then we can just decrement the pending bonuses. Hopefully that makes sense. So let's see if that passed our test. And it did. Yeah, it did. Excellent. So obviously we currently don't have spare handled in the logic, so we need a test case for that. So let's drill down and we'll do a test case for getting a spare. So scenario, getting a spare, and then a strike, and then nothing gives a score of, should we say strike? Let's do open, and then open, and then open frame of 7, 0, let's not say 7, let's say 5, 0, nothing, 20. Pretty sure it should be 20 based on the logic here, so let's just test it. So we'll say we got a spare, and then we got 5 and nothing. It is indeed 20. Cool. So what's the closest to this? Bold and strike, and then just 7. Let's handle the just 7 case. So this is 7. So we'll take that. And I need to handle getting a spare, don't I? I can turn this into a spare, it's fine. So it helps if you have a given, doesn't it? Right, so we're going to bowl twice. We have a score of, well, the spare can be whatever we want, so it only has 1 field, obviously, because you need to know the first one. So we'll say in the first bowl of the spare, which doesn't actually matter in this case, we'll say it's 6. So we bowled 6 and 4. Just double check that though. The spare, yeah, you can figure out what the second value was from subtraction, so we'll just leave that. And then we obviously bowled, expected to bowl twice. Let's close that out. So then I need to do 5, so I think we'll just clone this, can't we? No, this is the first frame, isn't it? Oops. 0, 0. I could use an incremented operator. Yeah, keep it explicit. And then, of course, we need to get just 5. So now, of course, it's going to be 1. It's just a gap there, so we need to separate. Let's split them up actually. When we bowl a spare, and when we bowl frame 5. So obviously fail, pass, open, 5, 5, 0. And when nothing, frames, so subsequent, that's how you spell it. What is it saying? No, it's just not updated. Okay. So obviously for bowling nothing, I already had something for that, didn't I? Which was this. So we've got 0. That should be 1. Pay attention now. So this is all 0s, 1s. This is 2 to 10. Bowl nothing. Then score of 20. Why is that? Oh, no, I did that. Cut that out a sec, kids. And that's it, right. So, as usual, check. Don't forget our commas. And hopefully it'll fail. Yep, all the mocks are correct, but 5 is clearly not 20, so let's fix it. So I'm going to go back to my visitor. It's actually I quite like this design as well, because the logic is fairly smooth. We've boiled this problem down to the idea that you just have a number of pending bonuses and to apply them as you go. And also, because this is a visitor pattern, you can potentially provide a running score with this, because it will compute the total. All we need is to add a counter for the pending, a boolean for whether there's pending bonuses, and we can instantly display a score like they do on a real bowling game, to leave it blank because there's pending bonuses, because you can't know the score until you've resolved anything pending. But anyway, enough of that. Let's focus on fixing our test. So obviously we scored a spare, and this implementation does literally nothing. I'm going to mark this as to do, because a common thing to do in code bases, you can search for to do's, and there's linters and checkers, and they will call you out for having a to do comment. So this is a fairly decent idiom to use in your code. So we need to handle the spare case. So obviously we know that we've got a score of +10, so obviously add 10. And then we can just say add 2 pending bonuses. And in theory, that is going to do it. Obviously this is not sufficient for getting, say, a strike and then a spare, but it works. Obviously it's making me think about it. So what we need now is to implement a strike and a spare. So what's the closest we've got to that? We scored strikes, no. We scored strike, no. Strike and 7. Yeah, that'll work. Yeah, we're going to take this one. So this is going to be fairly easy to modify. So, and spare next gives a score of 20. So let's just verify that. I'm pretty sure it's 20. Strike, spare, nothing. Oh, it's 30. Why is it 30? Oh, wait. Why Why do we 30? You get 20 on the first go. So 10 plus 5 is 15. Alright, okay, there's something I'm missing here around scoring apparently. Let's just make sure that's correct. Oops, I'll plug it out now. Strike, spare. Ah, alright, this is interesting. So, still counts. This seems to be a special case. Because we count the next 2 goes, but when it's a spare, okay, so listen, I might have to look up the rule book for why that is, but we bowl a strike and then a spare. Okay, so we can now say that's going to be a spare. So you've got, let's see if the score affects it. So if I bowl 5, I end up with 30. But what happens if I bowl 7? So we'll say we bowl a strike, 7. No, it doesn't affect it, so that's at least consistent. Run off the rest. Score 30. Okay, so it's obviously not going to work. Yeah, and of course we get 20 when it should be 30. So let's look at the rules here. Thinking bowling, scoring. The next 2 rolls. When a strike is bowled, the bowler is awarded the score of 10 for knocking down all 10 pins, plus he gets to add the total of his next 2 rolls to that frame. For a spare, the bowler gets the 10 plus the total number of pins knocked down on the next roll. Only. In the examples above, you can see the bowler roll a strike in the first frame, he gets 10 for that frame. Plus gets to add whatever he knocks down on the next 2 rolls. In the second frame, he knocked down 7 pins in his first roll, okay, that was 7. On his second roll, he knocked down the remaining 3 pins standing, so he gets a spare in that frame. And adds 10 more pins to his score in the first frame. He also gets a bonus for the spare, so he must wait to roll another ball before adding the score for the second frame. Gets the 10 plus the total pins knocked down on the next roll. So, I'm trying to work out this logic then, because if you bowl a spare, oh no, of course, think about it, of course it's 30. The strike gets the bonus of the next 2 rolls, which counts as 7 plus 3. So then the strike is worth 20. The spare itself is worth 10. So that makes 30. So it's all fine. All fine. You didn't think about the score of this spare, so this is all fine. You just need to implement it and it should work. So we have our spare. We just need to account for it. So what we say is that before we increment pending bonuses, we need to have a case for it. So if Does it matter? Yeah, it does matter. So pending bonuses is greater than or equal to 2. Total plus equals 10. And we just knock off those two. Else if 1, then we just had the result of the first shot we took, and we just decrement it. Strictly speaking, I shouldn't have done this. This is not tested. I might comment it out actually, just so we have a failing test. Yeah, let's do that. So, should still pass. Don't forget, if you change code, do run your tests again. And it does. But I need a test case for this. So, effectively, it's the result of getting 2 spares. So, if I get, let's say, 5, 5, and 5, 5, and then nothing, that should be 25. So we're just going to clone our existing one. This was for a strike though, wasn't it? Let's just do it. So scenario. Spare on the first round and a spare on the next gives a score of 25. Twice, so I can just cut this out actually, and do this twice. So, because I think it would affect the spare if you got a higher score. Let's just test that as well. So I get 5 spare, 9 and 1, and then nothing. That would be 29, so it does matter. So we'll say we'll go. Actually, let's go for that. So we'll say we got 7 on the first. That's irrelevant, and then we got a 9. That's a score of 29. So this is wrong. Right, so that's the 7s, that's the 9s, and then of course we just bomb everything else essentially. Then we should have a score of say 29, right? And it should actually say 29 then. Right. So in theory this should fail. And we do have a failure. Our logic says that what we do, we have 20, not 29. So that extra code that I ended up writing, which I commented out, should actually be the fix. So now let's just run it again, see if we passed it. Did we pass it? We did. So now we have a correct spare score, but we still have this sort of, well, spare with bonus concept, right? So this is the last frame. So if you, I think the key case to handle here is if you got a strike on the 9th frame, and then you got this spare with bonus case, then obviously we need to handle that. I'm not sure this spare with bonus is necessary. I suppose it is actually because of 10 frames, that special one. I think it's quite actually understandable. It makes it very understandable as to what's going on. So we need to obviously implement this, which means we need a test that will drive it, drive its implementation. So I'm probably going to, it's not really any test I can reuse for this, is there? Actually, there probably is. I can steal, what does this one do? Strike on the night frame and freeze on the temp. Yeah, this one's reusable. This is perfect. So, just screw around that. And just move this down a bit. And then we can do scoring a strike on the night frame and a spare plus bonus on the 10, which gives a score of 60. So the bonus could be a strike, but it makes no odds when you take that third and final shot on the 10th frame. It doesn't matter what it is; it's a max of 10. So we'll say the spare was 7 plus 3 plus 10, or we'll say 8. And let's see. So we're going to get. No. Reset now. What? 7 plus 3. No, strike and then. Yeah. So we get a strike, and then 7, and then 3, and then 8. Results in a score of 38. Given a frame set, one off on the first 8 frames, we bowl a strike on the night frame, and we bowl a spare bonus on the 10th final frame. So you're going to bowl as usual. Just need to alter this. And I said 7-3-8. I say 7-3, yeah, 7-3-8. So just to check the struct, it's 7 and then 8. We know that the second is free to subtract, so we can do that. So we'll do test frame set. Okay, so we've got 7 and then it's 8. And of course, we then expect a score of 38. 38. And then in theory that should not fail the box, should fail the scoring. And that has shrunk to, okay, we go, yep, and sure enough, we passed all of it. And we've got the scenario. I do like this scenario write-up. It's very readable for, well, pretty much anyone really. But we know we should have a score of 38, so we need to now write our implementation to pass that code. So we are going to do that. So let's pop up here. And we have, it's kind of getting a bit big. We should probably refactor it into a separate translation unit now, but it's okay. Okay, we can live with it. So we have our spare with bonus, and we've got to handle a case where there is a strike. Is reaching the point where I'm inclined, I could obviously just pass the test case. I can obviously just make this test case pass by adding whatever I need to add to make it pass. But I think that actually requires more thinking, because I have to like mentally in my head come up with the correct total plus equals whatever it is to sort of do the bare minimum than it would be to just correctly implement it in the simplest way possible. So I'm going to take a slightly wider brushstroke than usual with this, although not really by much, because it will help me make sense of it. So if we get a spare with bonus, we know first of all that it's going to be total plus equals 10 for the spare, obviously, plus the bonus plus score.bonus. If that makes sense, because obviously you have 10 plus score.bonus, that's the where is it? No, this is not. No, this is not. Bonus is just a bonus. It's not. It's you roll it because you got that. Then we need to essentially account for whatever bonuses are in front of us. So if we've just rolled this frame, how many bonuses could we actually have in front of us? Because we know this is the final frame. So there could be potentially the 8th frame is unaccounted for, and the 9th frame could be unaccounted for because the 8th frame might have been a strike, so it would have knocked off 1 on the 9th, and then that would have added 2. So what we essentially looking at, 8th frame would have 1 pending, the 9th frame would have 2 pendings, that would be a total of 3 pending. So it can't be greater than 3, but do we need to actually account for that? Probably not. Well, actually, if there's 3 pending, we just had 10 plus bonus. Can we have 3 pending? 2 free bonuses? Yeah, we can, because it was only possibly the 8th and 9th frame. 1, 2, 3. So yeah, we can handle that case fairly sensibly. So if pending bonuses is, I might refactor this afterwards. I'll see how it visually looks in front of me first. So if the pending bonuses is 3, we just do that. This could be optimized. I suppose. Well, no, it's so fast anyway. Who cares? Is that correct? I should be able to generalize this. What's the most that the 9th frame can look into? It would be, what would be 10? And yeah, the 9th frame would get a bonus of 10. Or would it? Plus. Yeah, it would only get 10, but we would subtract 2. And then for the final one, for the 8th frame though, we would only get the first. So I think it's better to represent this as a switch case actually, because there's specific cases and specific handling. So switch pending bonuses, and we can say that there's a case for well, if we get 2 strikes ahead of it, that's a case of 3. So we know that in that particular case, why hasn't that got an error? Whatever, I'll deal with it. It's that, it could be that. So if there's 3 pending bonuses, then the 8th frame is only going to get first. And then the 9th frame is going to get the spares value, which is obviously 10. So it's just the first value, the first thing bold, that's the bonus done for the 8th frame, and then 10 for the 9th frame, because that's what it is. So then we throw a case of 2. Well, we know now that the only thing that could be remaining is a strike on the 9th frame, because if there was a spare, then that would have been sorted on the previous frame. So that means there was a strike on the 9th frame, so we're just going to give it 10. And then if there was a spare on the 9th frame, obviously it's going to be that. Oh, there's a lot of white space there. And that's obviously the only possibilities. If there's none, if you have no bonuses, then there's nothing to do. In our particular case, though, I forgot to break. We don't have handling for these ones I thought of, so these are strictly speaking sort of somewhat illegal. This should be a case where, well, actually no, that's not true. We've handled this case, but we haven't handled this case or this case. So we're going to comment them out and see if it passes, and we'll drive them with a test if they are correct. And they are. So the question is there maybe a more generic way of addressing that? I don't think so. Maybe modulo? No. No, if the pending bonuses is no, because we need to know what to add. So we can't just add the first score. So I think that's sensible. But we need to drive these other two. So this one is the case of getting a strike on the 8th and 9th. This was the case of getting a strike on the 9th. And this is a case of getting a spare on the 9th, I think. Yes, it's a case of getting a spare on the 9th. Let's just handle a spare on the 9th, because that will require probably too much effort. Or actually, no, let's do strike on the 8th and 9th. That'll actually be a bit easier. First, right, so getting a strike on the 8th. And let's modify this now. We'll say 4, 6, obviously, for a spare. And 5, 10. We've gone off the first 7 frames. So that's 7. 9 frames. So I'll just copy that basically. Strike. Now we've got a spare on the bonus. So we said we got like 4, 6, 5. So that's going to be 4, 6 is implicit, and 5 obviously is the bonus. Then we should have a bonus of not 38, but I'm lazy and I'm going to go use a calculator to tell me. So we say nothing. 8th frame, we suddenly become amazing. That's 4, 6, 5. And that should be a total of 59 points. And that should do it. So let's just run it and make sure that nothing fails except the score. And sure enough, that is correct. So we can pop back up, and we should be able to uncomment this and just pass the test. And we do. Excellent. Very promising. So let me just take stock here. So this, I think, is handled. It takes care of that. If is there a problem with this? Just think about this. If you've got, how can you even have more than 2 pending bonuses? Oh, you can actually get 2 strikes. But won't that kill the bonuses? I think there might be a bug there. Let's think about it. If you get a strike, I'll probably mold this as a test case, but if you get a strike and then a strike and then an open, then one of the strikes is handled by this, adding the first and the second. But then it won't execute this. This should probably be an if, not an else if. So fine, mention the test case there. So that'll be strike plus 9. Right, we'll model that in a sec, but let's just go back to this. So we'll deal with this. We'll deal with getting this sorted first. And actually, that probably means that this is wrong as well. Let's just okay. So our case 1 is essentially a case where we had a spare. Let me get a spare. So let's model that. So not let's spell the first frame. Let's go start on that frame. So we'll just use this strike 1. Just grab that in there. This time we'll say 4 plus. Actually, let's do 2 and 8. So we'll say 2 plus 8 plus 6. Put up those frames. We roll the spare. There's a spare there. No, it's bugger. This needs to be a spare there. I'll just nick the spare from somewhere else. Yeah, I can. So what's this going to do? Well, let's just do it by hand. So we'll just shadow that, that's fine. Return false. So once, twice. And of course it's going to be a spare. We said the first, we don't care what the value of this is actually, because it's just going to work out to 10, so we'll make it 6. And then we've got spare plus bonus, which we said was going to be 2a6, so that would be 2x. And then that's a, yeah, roll twice, of course, not once. bold twice. Turns ended, no. Turns ended, yes. We get a spare of 6. And we've got that. We need to figure out the score. So our ruling said that we did thing. And on flight on the 9th, we're going to say we bowled 6 and then 4. And then we want to know 2, 8, and 6. 2, 8, 6. And that's a score of 28 apparently. So score of 28. And let's see if all the mocks are happy. Yep. So yeah, that looks good. Let's go right back up there. Good, it's frozen. No, it's back. And just on comments. Hopefully that will pass it. And it does. Excellent. So what we do need to take care of though, which I realise was wrong, is I need a test case for 2 strikes and a spare, and also 2 strikes and an open. So what do we have here where we get 2 strikes? Well, nothing close to that. No, it's too much. I'm going to try the 9th frame for 10, no. I'm going to try the first and 7 next, gets us that's fairly close. Yeah, let's go with that. So let's see, getting a strike on the first 2 frames, and I'm going to say 7. What do I propose in here? 6 or 9. Yeah, say 9. Right, so the score for that, let's find out what that should be. I get strike, strike, and then 4, 5, and then nothing. So it should be 52. Right, we bowl strike twice, and then just 7. So we can just clone this basically. Actually, you don't even need to clone it, just do 4. Shove that straight into it. Counter. Just makes it more idiomatic actually. And then don't need anything there. Just use I absolute everywhere. We said we were going to do 2 strikes followed by 4 plus 5. So it's 4, 5, and why is there a third value there? 4, oh, okay, it's total first. Makes sense. So it was a test. So that's actually 4, that's 5, that's 9. I should probably offer a constructor for this where you can feed it the 2 values and it will populate them, because it should know it knows that, right? Like it knows if you tell it A and B, the total is just A plus B. So we should probably clean that up, but we'll leave it for now. And then of course you bold. You bowl nothing for the rest, and then you should get a score of 52. 25, 52. Okay, that's ended. Right. So that should, in theory, do what we want. And it looks like it does. If the score's wrong. No, it doesn't. Okay. Whoa. Is that all just one scenario? Oh, please just be one scenario. Okay, it does. Okay, so that's fine. So let's have a look. Expected score to be called once, never actually called. Is that because I stuck it in that loop? Yeah, it is. Okay, I am going to put it in this. Stick you, shove it there. Okay, so that should solve that particular problem. I'm not sure if that's all the problems, but it's one of them. So let's see, I is 0, I is less than 2. It's going to be a strike. So that's 0, 1. How is it playing? When we do this, and when it should be in scope. It must be, because I would compile otherwise. This is correct. So it's going to be 0, then 1. Oh, no, it should be incremented actually. So, get 0, it gets 1, it gets 2, and it gets. That's not clever, is it? There we go. And I'm just going to reuse the variable. Make sure it still works. Yeah, we got our failing test case, so I figured that was going to be the case. So we need to essentially do that. Get rid of this, and it should work. Nope, it doesn't. Just make sure my test is correct now. So we're going to bowl a strike twice. It's going to be 0. It's going to be a strike. It's going to be 1. It's going to be a strike. And I is going to be set to 2, so it's not going to do it. Then I is set to 2 here. It's the same I that we had before. And that's going to be an open frame. 9 total. 4 in the first, 5 in the last. And let's go It's off by 4. Okay, so I think it's our code. Pretty sure it's implementation, so let's have a look. This is a spare. There should be 3 pending bonuses. So we know we just had 10. So this should be 3, so then it's set to 1, so then if it's 1, we add the first value, knock it off. And add that. So what have we done wrong? For the strike, it's going to be 10. So we call this first. When we evaluate the score for the first one, we add 10 for the strike. We have a pending bonus. No, we don't. So we don't do anything. But we do add 2. We then come to the next strike. We're going to add 10 again, so now at 20. We do have pending bonuses, so we'll add another 10, knock 1 off, add another 2, so we have 3 pending bonuses, a score of 20. We're going to visit the spare. We now have 30. We have more than 2, so that's then going to be 40. We knock 2 off, so there's 1 left. Oh no. Oh no, I've edited the wrong code. Let's just put that back where it was. It's not. I'm editing a spare. It's the wrong visitor. And let's just put that back where it was. Right. So now I've edited the correct visitor function. It does indeed pass. Cool. So we just need to add the spare now. And the best way to do that, of course, is we can reuse this basically as is. So we're going to bin that. And so we get 2 strikes, 6 and 4, half dozen of them. And that should be a total of 56. So 56. And of course we return spare. And there's only 1 value for a spare, of course. What should I do? Wait a second. Oh, that's the that's spare. And we said 6 on first, not the last is. And use a score of 56. So that should now be 56 as well. And it should fail. So let's give it a shot. And yeah, 50 does not equal 56 indeed. So go to implementation. We have this. We have that test case. It did change it slightly. That's fine. So if we've got 1 pending bonus, then we just add the first and knock it off. Hopefully that will pass. And indeed it does. So at this point, just looking through this implementation, I don't think I've missed any cases. We have handling of the spare bonus. We have the handling of, what else? Getting 3 strikes, because for each bonus you just knock off 10. Is that right? Yeah. We have our conversion operator, of course, getting the total, just for convenience. And what about in this case? If we've got a strike, and we just do that. Yeah, I think we've actually maxed out our test cases. The only real thing we could do now is is essentially test for confidence. You know, throw in some random scores. The problem is that it's not massively convenient to use these mocks in this way. We could do something. The thing is, it's nice to exercise all possible combinations of these. So we want to get. I mean, you can't exercise all possible combinations in one go, because you can't get 3 strikes at the end and a spare with a bonus. Those are mutually exclusive. But for example, you could get, you know, some opens, a couple of strikes, a couple of spares, spare with bonus. So you could potentially do something along those lines, but it's not really. Can't really think of much more to throw into that. Handle pending bonuses when it's opened correctly. We do when it's a strike. Yeah, I don't think there's anything more to add. So I'm gonna do the usual refactoring, to be honest. So let's start doing that. So we've got our frame set class. The question is, do we want to do a frame score visitor? I'm going to put that in the translation unit because it's internal. It's essentially internal to the frame set. Although alternatively it could implement them as. No, it doesn't. No, we don't want to do that. I was going to say it could implement them itself and update its own state, but I don't think that's really very clever. Purely because the visitor pattern is internal to the implementation, so there's no reason to expose that. I mean, we could interface it away, but it's more of an internal object. So let's do that anyway. So let's start out by creating our header. In fact, just to make sure that screw anything up. Yeah, there we go. So we're going to include and add a header file. Add a header file to include. So our frame set. Stick in both of these. No, thank you. GitHub, whatever. And then of course we want to go back to the frame set. And we're just going to grab this all the way to the bottom and cut it out, and we'll just paste it into our frame set class, header rather, and now we just need the declarations it needs, so national include array, and let's do the interfaces first. Essentially the local code, and then we need to include memory. But apparently somehow you magically get. Oh, do I need it for? Does iframe include unique pointer? No. Okay, that's purely by sheer luck that works. I'm going to include memory for unique pointer. Do I need CSTD in? Probably don't. That does include it. I'll include it anyway. It's good practice to include them because the interface might change. You don't know. Although, could it change in a way that breaks that? Let's see. Yeah, it's kind of exposed in the interface. You probably shouldn't expect it to, so I'm not going to include it because if the interface changed in a breaking way, I want to know about it. So that's one way to find out. What else do I need then? We have our iframe already. Is anything else in here that's all pretty much just maths? Yeah, okay. So let's see if it still compiles. No, it doesn't. This includes frame.h. Why do I include frame.h? I don't know. Good. Okay, so it still compiles. I definitely need array or utility. Hopefully, I don't know string, that's for sure. Oh, I need utility for reference, right? That's part of the test. That's fine. We do need vectors, so let's rearrange this a little bit. Alphabetical order is always good. And that somehow got munged. Let's fix that. Should probably include that first. Yeah, I don't know why I was complaining. Okay, it's not complaining anymore. So we can now go back to frame set, and we need the interface because it's a field of a class. I don't think there's anything else we need. So let's start shortening it. So we're going to create our translation unit. So we'll have a source file, and we'll call it frame set, obviously. Put it in the test, of course. And include frame set. And now we can just do a cut and paste. So we're going to go to frame set. The first thing that's coming out is this visitor. There's no reason for that to exist anywhere but the translation unit. So we'll shove it there. And that's now. I want to do something a bit more with this because I don't like necessarily having it implemented like this. I'll think about the visitor pattern in a minute. So it's all just refactoring at this point. We'll go back to frame set. We're going to cut the implementations out of it as well. So we'll snap these. Great, that's really helpful. Nab them out of them. And we'll head over to the implementation, paste those in. And we just copy that over, stick it on all of the functions that are members. And let's just give that an empty consistency. Go back here, just start reducing them to declarations. So that's a declaration, that's a declaration. That's basically it. I'm drawing them up just for completeness. And there we go, that's fairly compact now. We have our pointer to pointers to frame implementations we're going to use. We have our frame set. And that looks to be about it for that. So we go back to this, it shouldn't be complaining anymore. wrong. It's not lovely. So the last thing to do is just think about this thing. So the laziest thing to sort of do with it, obviously, is just separate the declarations and definitions and call it a day. But I'm not entirely sure what I'm thinking I want to do with it. But it is implementation specific. Yeah, I'm kind of on the fence about this one. There's several, because we could reduce this to lambdas as well. We could do a bit of boilerplating, and we could squeeze all the code into the score function. It's probably not as readable that way. It's probably better the way it is. I think I'm just going to separate it and put it underneath. So let's do that part. So the simple way of doing that is grab all of this, and we're just going to copy, shove it underneath the declarations and definitions. If the declaration comes before, the definition can come at link time if you want. And then of course we just need the class name stuck in there. Just stick it on all of them. I believe that's the way to do it, isn't it? Yeah. And now we just reduce these two declarations. And that's 1, 2, 3, and 4, and 5. Very helpful. And then 6. And then that's fairly compact. We have our score function, we have our operators. I don't know why it's complaining about spelling, it's very silly. It's the conversion operator. Let's just try it. Does it still compile? And run. And the answer is yes. Yes, it does. So in terms of this implementation now, I can't really think of anything. Let's do some spacing out. I can't really think of anything I'm particularly unhappy with in this design. You can always get a total out of it as it's running. Maybe I want it to give me the sort of, what's the word? Pending score, potentially. But I think that's going to be a feature for the future. So this is essentially a usable set of code. I'm going to get rid of this stuff though. Let's get rid of this. Can't read. Oh, I see. I'm start getting rid of stuff. So we're going to get rid of that, and then we're going to get rid of that, and then we're going to get rid of that as well. Should have removed that. Didn't remove it. So much for safe deleting. Alright, let's see if our test still runs. No, it doesn't. Okay. Don't know why that's there. Yeah, okay, good. So we have a relatively clean set of unit tests. We have something that can score for us. So I think the first thing I'm just going to do, just for the fun of it, is we're going to have a main, and we're just going to do some integration, just play with it. We should obviously do integration tests to plug all these interfaces into each other. But now I'm just going to do a simple test and try and score with it. So let's include our frame set, include frame.h, sorry. Inset. So we've got a frame set, and a set of pins. Top frame, so it's sort of hierarchical. That's not working because I need to fix the CMake list. I do. So let's just grab that. This was an attempt to fix up the linker. Didn't help in the end. I just switched to Visual Studio. Now it should work. In theory, it does. So we need to bold this. So we need to construct a set of frames, and then we need to construct a frame set. So let's see what the contract is to make this one, because don't forget this won't even compile if we've not satisfied it. So I need to give it an array of unique pointers to some frames. So we can set that up fairly easily in our main. So we can have array we want to do frames 0 to 9, not 0 to 9, 0 to 8. That's already written. So we do frames unique. And does that need any arguments? I don't think it does. It does. I need to give it some pins as well. So we can go back to our main. This is all compiled, so this is all compile time. So also in fact, I don't need that. I'll just give it to it directly to be simpler. And then okay. So then we have our set of objects, and we can of course now give that to our frame set. So and of course now the only thing left to do is bold. So the only question is, how do we want to simulate the bowling? Let's do something trivial first of all. Right? Let's generate a random number we're going to generate a random number, and we'll bowl until it says the turn has ended, and we'll print out the numbers, and I'll punch them into a calculator, and we'll see if if the scores match what we should have got. So we're going to include random. And now we just need to set up the device. So we'll have in fact, we'll just stick it above this. I don't really need numbers that much. And then that's seeded with. I could probably just use random device on a pretty modern Intel CPU. I'm pretty sure I've got RDRAM. I'm pretty sure we use RDRAM. But then again, it is the Microsoft compiler, Microsoft standard library, so who knows? This should be good enough. I don't need cryptographic security here. Okay, so we've now got our random number device. I can't remember the API of that thing, so let's see, MT19937_64. Please don't take me to our website. It's not a good reference. CPPReference.com is the good reference. Let's see, operator parentheses gives me what? Independent max, which is a really big number. I can just do %10, can't no, I don't want %10. Can I do that? So let's say if we add one, so we do 10% of 10, obviously 0, isn't it? So I think it's 3. And then generates 0, that's obviously 0, it's 1, and that's 0. Oh, I'll do it the wrong way around. That's it. 9 would be 9, so 0 to 9. Okay. So let's try this. While the game hasn't ended, we're going to first of all calculate how many pins we're going to knock down. So auto so that'll give us a number in the range of 1 to 10. And then while actually, I don't even need to add 1, do I? So we post to decrement. So I don't need +1. So while pin's knocked down, we're going to do. I mean, we can randomly knock down pins, but yeah, screw it. I'll just do that for now. So pin, and I ended up using my static cast after all. So pin set first. Actually, no. I need to take it in turn. I need to take turns though, simulating this. If I do a pin set, I might actually extend it slightly. Knock down pin. I'll just knock them down in order. It doesn't really affect the scoring for this simulation. The idea of that originally is that you can knock down specific pins. You can call them back or get them back later. So we're gonna get 2 bowls. So if you're gonna knock them down across 2 turns, I think what we'll say is that if you say pins down first turn, and then we can say, so while pins down first turn, actually we'll use a for loop for this, I think. So for 0 less than. Then obviously what we're going to do is we're going to do pin set. Should I declare it outside of it? Yeah, that's no, it can't be it now. That wouldn't make sense. So we're going to knock down that with pins, and then we'll find the bowl. So actually, I don't need to do any more, do I? Like, actually, not going to do because I've got. If I haven't finished the turn. I don't know the total yet, do I? Yeah, this is a question. If I can check, actually, well, I can just check, can't I? No, can't check if this roll has ended. It doesn't tell me. So I technically need to put. I need more. I need a better, more features in my API to make it more convenient for this. But again, this is where you use something now and it works, but you discover you want to make it more convenient to use, basically. So we're going to bowl those pins. So let's say if first turn is less than 10, we'll do some special handling to bowl again. So what can we say? Greater than pins down first turn. Although when I pass it the pins on the frame, how does it handle that? It just doesn't. Oh, it just doesn't and right, so it should be the same. Well, we'll find out, won't we? If that's greater than that, then we need to knock them down. So just copy and paste this basically. It's not really the most optimal code, but so then we've reduced it. Bold again. I just need to bowl either way, so just reuse the object. So now we've bowled either way. So what do I need to have printed to the screen? So the first thing, of course, is my score. So oh, but I'm not. Oh no, I'm not handling the bloody third turn on the last go. Let's do something simpler. We're just going to generate a random number. If it's less than 10, we'll bowl it twice and nothing will happen. And if it's not, we'll bowl it once. So you can't technically get a spare, but it should be good enough for calculating scores. So it's less than 10. Just use it again. No, that's not going to handle the class. That's not going to find the So we'll keep going until the game has ended. You know what? I can figure it. I'll have to figure this out a bit slightly manually when I see if the score is correct. But we're gonna do it. So we will print out bold. So I'm just going to put pins down. And we'll just have a counter for the number of turns taken. So and just for speed, because it's going to simulate and then finish anyway. And then just another one. And we can run that, hopefully. Run bowling simulator. No. I want to run something different. Yeah, there we go. That's not very good, is it? So somehow the frame set has immediately ended. Yeah, it doesn't do that in our test, so what do we do wrong? Oh, we never tested it. Yep, that'll do it. Alright, that's fine. I probably can. Yeah, I'm just gonna add the check to an existing test rather than bung another one in, because it's a simple one-liner anyway. So what are we gonna do? That's no good. There's one where we bowl a subset of the entire game. Not that one. This one is one. Fire. What's it called? Okay, so now we can run the test again and make it work. That's pretty hard to cheat. Yeah, cool. So now I think the simplest way to solve this is just to for that's bugged. Oh, breaking all the tests now. No, because I didn't. Oh no. I have no implementation in my mocks for this. You know what? There's a better way actually. That was a silly way of implementing it anyway. So current frame. So yeah, that's a better way of doing it, isn't it? So just do I'll do it without busting it. Yeah, that was much more sensible. So once we cross over, we're done. Should have a safety check here. You crash horribly, but that'll be good enough for our test. So we go to test main, not test main, sorry, now it should work. Well, say that very cautiously. No, it did. So we took 20 turns, which is 2 times 10. So you know that we what we did. So I didn't actually print the score, which is silly. So right, let's actually do something useful. So you took 20 turns. Is that 10 correct? So I get 9 pins. 9% 10 is 9. 10 is, no, it's not. You can't ever get a strike with this. If we set to 11, then you can, so we'll do that again. We'll get some strikes now. There we go, we took 19 turns. We got a strike there. Excellent, okay. We've got a couple of strikes. How did we take 19 turns then? Alright, let's simulate this. So we're going to pop over to our lovely bowling genius thing. bowlinggenius.com, and we're going to say we got, wait, how do you get 10? Oh, it's just going to become a strike, isn't it? So we say 8, 2, that's a spare, and then 3, 4, 3, 2, 3, 5. One, 5, 5, 5. 10 would mean another 5 basically, so 5, 5, 4, 2, 2, 5, 4, 2, 2, 4, 5. No, that doesn't help at all. It is not much. So I did something wrong. Can we give the turns taken Alright, let's do that. So done. There we go. So start again. So we bowl 8 on the first turn, then 5. No. I need to. Okay, it's my fault. So if you got 5. Yeah, I think it is correct. It's just I can't add it up. The problem is that we bowl 8, but then 5 is less than 8, so it's not going to count for anything. So it's effectively 0. Then we bowl 4, and then we bowl less than 4, so that's effectively 0. Then we bowl 1, then we bowl another 1. Oh, screwed up scoring now. Let's try that again. Right, so we bowl 8 and then nothing. We bowl 4 and then nothing. We bowl 2 and then 1. And 5, 4, 1, 2, 3 is +1. We bowl 2 and then nothing. We bowl 4 and then nothing, so that's effectively 4. So 4. We bowl 4 and then 0 again. We bowl 2 and then nothing. We bowl 10, so that's a strike. We bowl 1 and then 9, so that's effectively 1 and 8. And then we finally bowl 5 plus 2. For a final score, according to bowlinggenius.com, of 62, and our final score is indeed 62. So, and correctly, you took 19 turns because you got a strike, but you didn't get one at the end. So, for generating random numbers, that's pretty good. The thing is, I need a better API for this. Obviously, you can see we are scoring correctly. The problem is that this is a bit too stateless and doesn't know quite what to do, but it does work. It scores you absolutely correctly, at least from that random number test that I've done, where we did score 1 strike at one point. Let's do one more run, and then I'll round this off. I might do a part 4, or maybe do a quick one. But I'll push this to GitHub anyway, because it's the implementation that's done and you can work with it. So one more run. Okay, so here we go. So we're gonna have a game, and we got a strike on the first go. Look at that. So that's a strike, and then we bowled effectively 8 and nothing. And then we got 2 on the first one, plus 6 minus 2 is 4, so we went with 4, that's a total of 6. We bowled 8 and then nothing, so that's 8, 0. We then bowled, what's that, 5 and 3, so that's just 5 and nothing. It's not really great for RNG because you keep failing on these other ones. Well, we bowled 4 and then another 4, so that's 4 and 4. We bowled 1 and then 6, so that's 1 plus 5. We bowled 5 and then 8, so that's 5 plus 3. We bowled 7 and then 5, so that's just 7 and nothing. And finally we bowled 8 and nothing, because it's lower. For a final score, according to Bowling Genius, again of 82, and we do indeed have 82. Grand total of 19 turns. So it does look like this works quite nicely. Just that this doesn't currently know what frame you're on, so we should extend the API, but I'm pretty pleased with that. We have a working bowling scoring implementation, and there's probably things we can do with it to extend it, so I might maybe not do a part 4, but call it a, what should we call it now? I don't know, I think the new chapter in the story, whatever. Anyway, for those who've enjoyed this, thanks for watching, and that is how you build the basic logic for a working bowling scoring simulator, with a little bit of random number generation in there just to exercise it a bit. Anyway, thanks very much for watching. I'll see you next time.